Hey, how you doing, 5th and 6th grade? Been off for a whole week with no school. How about a little bit of science? You ready? Okay, here's what you need. If you have it, get your science book. You need a notebook and a pen or a pencil, okay? Give you a minute and a second to go find those things. We're going to cover chapter 3 out of our book. We started this just before we had to leave school, about plate tectonics. Don't forget about science fair. If you can do that at home, go ahead and work on that as much as you can. Also, there's iReady, there's SumDog, and TTM. Don't forget about those things, okay? So, get the notebook, get your textbook, and a pen or a pencil. I'll be right back. See you soon. Okay, welcome back, everybody. We're about ready to start here. Hopefully you found a notebook, something to write in, and have a pen or a pencil. So we're studying chapter 3 about plate tectonics. So go ahead and get that at the top of your page. And here's a picture of Alfred Wegener. You remember him. We watched a video. It was animated a while back, telling his story. He talked about drifting continental theory. He claimed at one time all of the Earth's land masses were one giant island called Pangaea. Now, at the time, he didn't have a lot of evidence about this. But later, we did find out the following. First thing is that the fossils found in South America and Africa are identical to each other. Now, imagine that. Fossils of animals that can't fly and can't swim are found on 2 separate continents separated by the Atlantic Ocean. Something fishy there. So there had to be some reason that both continents had the same fossils on them. Also, there was the discovery of Glossopteris, an extinct plant found in Africa, Australia, India, and Antarctica. Now, how could a plant that can't get across water show up on all those different places? Okay, again, I'm going to move ahead a little quicker than you're used to in the classroom. Don't forget, you can just pause it and write down the notes as we're going along. So here we go on to a new slide. Other evidence included rocks of the exact same type found in Africa and in South America. And then there's a mountain range that starts in Africa and continues on across and lines up with the mountain range in South America. So what caused all these different land masses to separate? Here's the story. It's called spreading ocean floor or mid-ocean ridge. It's found in the center of the Atlantic Ocean. There's a gigantic crack through the Earth's crust. It was discovered back in the 1950s and 60s as we had new technology, sonar mapping of the bottom of the ocean. Scientists up to this time actually thought the ocean was probably pretty flat, maybe even like a beach filled with sand. We know that's not true anymore. We know there are mountain ranges and valleys. We discovered that magma is forced up and spreads the ocean floor apart. So let's pause for a moment here and let's bring up a video. We'll watch that together and then we'll come back and take a little bit more notes.
Are you sure this thing is rated for this depth? You bought it from an air mall catalog. Oh, great. Dear Tim and Moby, when I look at a map, it seems like some continents fit together perfectly. Are my eyes playing tricks on me? From Georgia. You're not seeing things, Georgia. Some continents look exactly like puzzle pieces that snap together. Early map makers suspected that they were once all connected. In the early 20th century, a scientist named Alfred Wegener called this supercontinent Pangaea. He thought different chunks of it broke off and slowly moved apart. Over millions of years, they formed the continents we know today. Wegener couldn't explain why Pangaea split up or how. But there was some evidence to support his idea. Fossils from similar plants and animals had been found oceans apart. The age and type of rock layers matched up too. Wegener's theory of continental drift provided an explanation, but his ideas weren't taken seriously until long after he died. In the 1950s, scientists began mapping the Mid-Atlantic Ridge. It's a mountain range running 10,000 miles along the ocean floor. Tests revealed that the farther you got from the ridge, the older the seafloor was. So a geologist named Harry Hess proposed a revolutionary idea. New seafloor was forming at the ridge and spreading outward to make room for more. In other words, the surface of the planet was moving. Hess called this process seafloor spreading. It seemed to indicate that rock was being forced up from inside the planet. Nowadays, we can see this rock formation in action. Wegener had guessed something like this, but he had no way to prove it at the time. As he suspected, there's a lot going on beneath the Earth's surface. Up here, everything seems pretty cool and stable. But miles below our feet, it's a raging inferno. The deeper you go, the hotter it gets. Earth's center, or core, is as scorching as the surface of the sun. All that energy wants to escape like steam inside a boiling kettle. It pushes outward, putting immense pressure on the middle section, the mantle. Standing in its way is the lithosphere, a rigid layer of solid rock. Well, the lithosphere isn't like a smooth shell. It's cracked into pieces, each one a different shape, size, and thickness. We call those pieces plates. Yep, the Mid-Atlantic Ridge is the border between several plates. They're being dragged apart by forces from deep inside the planet. You can think of it like a pot of soup. The Earth's core is the burner, and the mantle is the boiling soup. As the soup near the burner heats up, it becomes less dense and rises. When it gets to the top, it cools off and sinks down toward the heat. In physics, those are called convection currents. A similar process is driving the mantle, and it's taking the plates along for the ride. That movement is called plate tectonics. It's the engine driving the constant transformation of our planet's surface. Plates have been bouncing off each other for eons. The oceans have expanded and contracted. Land masses have smashed into each other and broken apart. The plates move about as fast as your fingernails grow, so we don't see the ground sliding around under our feet, but we do sometimes feel it. Yep, I'm talking about earthquakes. Seismic.
Okay, so we're back at our notes again. This was the last page that you saw, so let's go ahead and advance it. Got your pen ready? Let's write some more down. Now, on the other side of the Earth, on the opposite side of the mid-ocean ridge, is something called the subduction zone. It's where the old floor is forced back into the Earth. It is opposite of the mid-ocean ridge. The Earth's moving plates, Roman numeral number 3. We call this plate tectonics. That's where the word comes from. The lithosphere is the topmost part of the Earth's crust. It's what we walk on, we build our buildings on, and our roads. There are 7 major plates, many smaller ones. Plates move into, under, across, and away from each other. And again, I'm going to move quickly, so you feel free to pause at any time to write things down. And finally, our last slide, there are 3 types of plate boundaries. They include the divergent boundaries. Divergent means to move away from each other, so the plates move apart. The convergent boundaries, where they come together. And the third one, transform boundaries, in which the plates slip past each other. Plate movement is caused by the convection currents that we saw in that video. Hot magma rises. As it cools, it drops down again. It sinks. It creates a rolling movement that the plates move across. Okay, let's go back to that video. You can always come back and write down the notes whenever you get a chance.
Talking about earthquakes. Seismic activity is greatest along plate borders, at convergent boundaries where two plates collide, at divergent boundaries where they pull apart, and at transform boundaries where they slide past each other. At all three boundaries, there's enormous pressure on the Earth's crust. That's the topmost layer of the lithosphere. The pressure can build up for years. The longer it takes to release, the bigger the earthquake. Yep, and plate movement drives volcanic activity too. At divergent boundaries like the mid-Atlantic ridge, there's a gap in the lithosphere. So magma, molten rock from the mantle, is constantly pushing up along the boundaries. These are the most volcanically active places on Earth. Volcanoes are also common at boundaries called subduction zones. That's when a dense ocean plate converges with a lighter continental plate. The heavier plate gets pushed below, down into the mantle. Some of it melts, and the magma erupts farther inland. The Ring of Fire is a massive chain of these volcanoes. Dense sedimentary rock making up the Pacific seafloor is subducted, transformed into metamorphic rock through pressure and heat, and then recycled as igneous rock through volcanic eruptions.
Okay, the next thing I'd like you to look at is this website. I'm going to put it up on the screen here. Hang on a minute. We saw all this already. Here we go. geographyforkids.com/file/earth_tectonics. So go ahead and write that down in your notebook. So a little later we can go to this website, but I'm going to show you what it looks like when you get there. So when you type in the address, this is what will come up on the screen. Gives you some information here. Please read through this. It says plates are moving beneath you. It's going to talk about that. It'll talk about, do they really float? It'll explain that part. So we scan down, they'll give us the scientific evidence that's out there. And then it'll bring up this video. I want you to take time to watch it. Just go ahead and click right here. It'll take you to YouTube. You can watch that. And then when that's done, come back to this screen. And we're going to look at the quiz that's here. And we're looking at this one right down here that says Tectonics, the bottom one. So I'm going to go ahead and click on it. It's going to bring up the first question here, and that is, before the continents separated, the original landmass of the Earth was called. I know we all know the answer, but let's go ahead and do the wrong one just to see what happens. So if I do click on that, it'll tell me I'm wrong. Okay, it'll explain which was the right answer, so we're going to go ahead and restart that quiz. This time we'll do it correctly. And it does tell me I'm correct. We're going to go down here to this part right here where it says next questions and click right on top of there. See how many you get right, okay? Let me know when you contact me later. Okay, there's that website again. But now I got a challenge for you. Here are 3 questions you can write down. Let's go through these together, see if you can come up with the answers. Number 1, which type of plate boundary movement could cause a new body of water to form? Number 2, which type of plate boundary movement could form a new mountain range? And number 3, which type of plate boundary movement can create a fault like the San Andreas Fault? So what I'd like you to do is go ahead and email me at mr.mick.cos.scienceclass@gmail.com. Give me those answers. I'll get back to you. Don't worry about if you get them right or wrong. Do the best you can on them. I'll let you know how you did. And even if you just want to say hello, you can email me at that website. I'll leave it up there for just another second. Okay, we're just about done. Do me one more thing here. Read the first section of the book and answer page 59, the 3 questions, and then you can email those answers to me. So, we'll see you in about a week. Good luck to you and your family. Hope you're healthy. Come Friday, wear your spirit wear. Bye, everybody.